Hello, welcome back to this channel. In today's tutorial, we are looking at a very interesting topic in mathematics, logic or logical statement. Now, when we say a logical statement, it's a mathematical statement that is either true or false. What do we mean by either true or false? Logical statements cannot be true and false at the same time. So it is either the statement is true or the statement is false. For example, if we are saying that the sun is hot. So if we say that the sun is hot and it's not hot at the same time, this is not a logical statement because the sun cannot be hot and cool at the same time. That is what we mean by logical statements. So it's either the statement is false or the statement is true. Normally, we usually denote logical statement by upper cases. In rare cases, normally do we denote them by small letter cases. Now let's look at this particular table that we have here. We are seeing that if we have two statements and we combine them, then we are having a conjunction, and that the statements, both two statements must be true at the same time. That is conjunction. So here the A represents one statement and B represents another statement, and that both statements must be true or false at the same time. But for two statements to be conjunction, what we mean is that if one statement is false and the other one is true, then the result is false. And if the other one is false and the second one is true, then the statement is also false. And so for conjunction, both two statements must be true or false at the same time. And if we talk about negation, if you give an example like Amma is a girl, the negation of Amma is a girl is Amma is not a girl. And the symbol for negation is what we have here. So Amma is not a girl becomes the negation of Amma is a girl. Implication. If A implies B, this is the symbol for implication. And what do we mean by A implication B or A implies B? A typical example is if I study hard, I'll pass the examination. So A implies B means that if I study hard, then I'll pass the examination. And if I do not study hard, I will not pass the examination. So A becomes sufficient for B, and that if I study hard, then I'll pass the examination. And then equivalency is that it is A if and only if it is B, and that is the symbol for equivalency. Now, let's look at this particular question. Examples of conjunction disjunction is used in this particular statement. In this open interval, we have 1 and 3. Then if we say that A is greater than 1 and X is less than 3, it is only true when this is an open interval. That is, X is greater than 1, X is less than 3. This statement that we have made here can only be true when X is in this open interval. Now, let's talk more about negation. We have these two statements over here. P, statement P, Amwa is a boxer. And then we have statement Q here. Amwa is not a boxer. Then the P negation Q is written as Q equals negation of P. So when we negate P, then we get Q here. And the statement for P is Amwa is a boxer. And that of Q is Amwa is not a boxer. Another definition of negation is not P. It is not the case that and is denoted by this. Let's look at a truth table for negation. So if we have a statement P and it is true, the negation of the true statement is false. And if we have a statement which is false, the negation of a false statement, it is true. So let's say we have Amwa is not a boxer. Then we negate that statement. We are going to have a true statement, which is Amwa is a boxer. For example, consider the statement P, the integer 2 is even. Then the negation of P is the statement it is not the case that integer 2 is even, or the integer 2 is not even. It would be better to write in this way, the negation of P as the integer 2 is not even, or better written as the integer 2 is odd. Now let's talk about the next item here, which is conjunction. So the conjunction symbol is this. The conjunction P conjunction Q is true only when both P and Q are true at the same time, or otherwise P conjunction Q is false. So for conjunction, both two statements must be true before it is true, or both statements must be false before it is true. So both P and Q should be true at the same time or false at the same time before it is true. So for example, if we have a statement P, the integer 2 is even, and statement Q, it is less than 3, then P conjunction Q is written as the integer 2 is even and 4 is less than 3. This is a false statement since Q is false, because with the statement for Q, it is less than 3 and 4 is not less than 3. So since this particular part of this conjunction statement is false, then the entire statement is false. So the integer 2 is even 4 is less than 3 is a false statement since Q is false, even though P is true. The P statement is true, but the Q statement is false, and that makes the whole conjunction statement as false. The truth table for the conjunction of two statements is shown below. If we have two statements, and we are saying that both statements must be true before they are true, or both should be false at the same time, then it is false. So if you have a true statement, then it is true. But if you have a true statement in conjunction with a false statement, then it is false. If you have a false statement in conjunction with a true statement, then it is false. If you have a false statement and another false statement, that is false. Now try this. Determine the truth table for the following. 3 is a prime number and 3 is greater than 4. Now let's look at disjunction. For disjunction, given two statements P and Q, the disjunction is written as P or Q, and it is noted by this. Sorry for the error. The disjunction P disjunction is true when at least one of the P and Q it is true. So if one of the statement is true, then it is true, or otherwise P disjunction Q is false. Unlike conjunction where both statements must be true before it is true, or both statements must be false before it is false, for disjunction, at least one of the two statements must be true or false. Therefore, P conjunction Q disjunction Q is true if exactly one of the P and Q is true, or if both P and Q are true at the same time. Let's look at P conjunction Q. Sorry, P disjunction Q. The integer 2 is even, or 4 is less than 3 is a true statement. Since at least one of P and Q is true, that is, the first statement is true, but the second statement is false. But because it's a disjunction, then it is true because at least one of the two statements is true, which is of course the P. In this case, P is true. So for the truth table for disjunction, true is true because we said that at least one of the two statements must be true. So if we have both statements to be true, then it is true. True, false, true, because we said earlier on that for disjunction, one of the two statements, at least one should be true. False, true is true, and then false, false is false. Let's look at implication. Consider the following compound statements. If Emmanuel is a policeman, then he is dishonest. From the above compound statement, two information can be deduced from Emmanuel. Why? For example, if Emmanuel is a policeman, Emmanuel is dishonest. The compound statement P shows that if E is true, then F is also true. In that case, if Emmanuel is a policeman, definitely Emmanuel is dishonest. So this implies this. This is what we term as implication. Thus, E implies F. E implies F means that if Emmanuel is a policeman, definitely then Emmanuel is dishonest. And that is what we call implication. So we call P the hypothesis of the implication and Q the conclusion. So if Emmanuel is a policeman, then Emmanuel is dishonest. So if Emmanuel is a policeman becomes the hypothesis of the implication and Q being the conclusion. The implication written as this can be expressed in words in several ways, such as if P, then Q. If Emmanuel is a policeman, then he is dishonest. P implies Q. Q if P. P only if Q. P is sufficient for Q. Q is necessary for P. These are some words that we use for implication. Now let's look at the truth table for implication. True, true, true. If Emmanuel is a policeman, then he is dishonest, and that is true. If Emmanuel is a policeman, and he's not dishonest, true, because Emmanuel is a policeman. One of the statements is true, and then here false, true, then false, false. If Emmanuel is not a policeman, then he is not dishonest, and that is a false statement for the implication. Now let's look at a converse. It is a reverse form of statement. Consider the statement below. All policemen are dishonest. All dishonest people are policemen. All policemen are dishonest. All dishonest people are policemen. F is the reverse of E. So we are reversing this and this. All dishonest people are policemen. All policemen are dishonest. So a reverse of E is the reverse of E is F, which is of course all dishonest people are policemen. It's called a converse. Therefore, F is said to be the converse of E. The converse of E is not true. Why? If all policemen are dishonest, it doesn't mean all dishonest people are policemen. That is why we are saying that the converse of E is not true. All policemen are dishonest necessarily doesn't mean that all dishonest people are policemen. So we write the converse, inverse, and contrapositive. So we are given an example to write the converse, inverse of the statement below. If today is Saturday, then I'll go for a 10 kilometers run. Let's P and Q be the following statements. For example, let's give P be the first statement and then Q be the second statement. Today is Saturday, then I'll go for a 10 kilometers run, 10-kilometer run. Then the given statement can be written as P implies Q. The converse of this statement is Q implies P, which is this. If I go for a 10 kilometers run, then today is Saturday. That is the converse of this statement. And the inverse of this statement is P, negation of P, negation Q. Meaning, if I do not go for a 10 kilometers run, then today is not Saturday. The symbols for compound statements, negation, conjunction, disjunction, and implication are sometimes referred to as logical connectives. So a compound statement is a statement made up of one or more statements with statement variables such as P, Q, and R, and at least one logical connectives. Okay, so let's look at a typical example here. Write each of the following statements symbolically. Let P and Q be the statements. Write each of the following statements symbolically. P, it is hot, it is sunny. Then we have our first one, it is not hot and it is sunny. So in this case, it is not hot becomes negation of P. Then we put that one in brackets. And is conjunction. It is sunny, kill. So that is what we have here. It is not hot means negation of P, and means conjunction, and it is not sunny. So we have it is not as a negation of P, and its conjunction, and it is not sunny as well, which is a negation of Q. So under this example, we are to construct a table for the compound statements. P implies Q, conjunction, Q implies P. So here we need to create a column for P and Q separately, and then P implies Q separately, and Q implies P also separate, and then at the end we put the two together. So we generate the column for P as true, true, false, false, and for that, and for Q, true, false, false, true, false, true, false, true, false. Here the arrangement matters so as to avoid repetition. A case where we will have true, true, and true, true here at the same time, and therefore the arrangement is very important. So for P implication Q, that is P implies Q, true, true is true, true, false is false, false, true, true, false, false is true. And for Q implication P, we have true, 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 false, true, 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 false, false, and that of false, false, which is true. Now, P implies Q, conjunction Q implies P, means that both the two statements should be true to be true or false to be false. So we have true, true, which is true, and then we have false, true, false, true, false, false, true, true, also true. We have another example here on compound statements, and this is the question. And so we need to generate the column for this separate, and then we have P disjunction Q, that one to separate, and the negation of P disjunction Q, and then after that we generate a column for Q conjunction P, then the last column will take care of this. So as I said earlier on, the arrangement of the table really matters, so as to avoid repetition. So in this particular table, the junction for P and Q is true. That is true, 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 false, true. So we said at least one should be true. False, true, true, false, false, false. Then the negation of all these will give us, so the negation of true, false, negation of true is false, the negation of true is false, and the negation of false is true. Then P conjunction Q, both should be true to be true or false to be false. So we have P conjunction Q. So true, true is true. Then true, false, 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 true, false, 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 false. Now we compare this column to this, and that is implication. For false, true is true, false, false, true, false, false, true, true, false is false. There's another interesting one called biconditional. For statement P and Q, we are interested in both the implication and its converse. So P implies Q and its converse is Q implies P. When we put these two together, then we have what is called biconditional. So given two statements P and Q, the conjunction of these two, the implication of this and this combination is called a biconditional of P and Q, and it is denoted as this. P, P biconditional kill. So the biconditional of P and Q is normally stated or often stated as P if and only if Q. P is equivalent to Q. So now let's look at the truth table for biconditional. True, true is true, equivalency. False, true, false. True, false, false. False, false, true, because of equivalency. And let's move to the another interesting and funny one too as well, tautology. Now we are saying that for tautologies or tautology, a compound statement is called tautology if the true values of S is true for any assignment of true values to the statement variable occurring in S. Now let's use a real life example. A statement that is always true is tautology. Example, it will either rain or not rain tomorrow. So it will either rain or not rain tomorrow. So the reason why this statement is a tautology is that this statement is always true because it is impossible for it not rain and not rain at the same time. It is a certainty. So it is either it will rain or not rain tomorrow. But it will be impossible for it to rain, for it not rain and not rain at the same time because it is a certainty. So in this example, we are to show that the compound statement P disjunction negation P is a tautology. So P true, the negation of P is false. So the negation of false statement is true. So here is true. And then the negation of this false statement is true. Sorry. Then which one? This one too is also true. Now let's look at a contradiction. A compound statement called S is called a contradiction if the true value of X is false for any assignment of true values of the statement variable occurring in S. Now let's use a real life scenario. So a contradiction, a statement that is always false. Example, it is raining and it is not raining at the same time. This statement is always false because it is impossible for both conditions to be happening simultaneously, and it is a logical contradiction. It's impossible for both conditions to happen at the same time or simultaneously. So this is a contradiction. And therefore, the compound statement, the true statement for a compound statement for contradiction is true. That is a true false gives us a false statement. And then a false statement and a true statement gives us a false statement as well. So this is what we call a contradiction. Thank you, and don't forget to subscribe to our channel.